So these letters on the board kind of get all jumbled up unless we know where to start and stop reading a word. And in our language, and I think in probably most languages, we add spaces, but those spaces are really just a cue to start reading a word and where to stop reading a word. Now, if we kind of use a similar analogy, were you ever supposed to read a passage and then answer some questions, but maybe we were not really wanting to read the whole thing? So we said, hey, there's this, oh look, it's asking me about this one person or this one word, this is one definition. And then what do? We just kind of go, oh, found it. We skim, right? So we're like, oh, there's the word. I'm going to read. Okay, I got my answer. I'm only going to read this section. I visually keyed in on the word. That was where I started to read. Once I got to the end where I said, okay, I know my answer, I stopped reading. It's kind of the same idea. There's more information than we need. We cue in on a specific section and only the section that we really care about. These are kind of meant to be like an analogy or a model to talk about DNA. DNA codes for a message. And the message that it codes is ultimately for proteins. And proteins, that message on how to build a protein comes from assembling a certain sequence of amino acids. Just like words, we have to put the certain letters in order to make a word. We have to put amino acids in a certain order to make a protein. In order to determine what amino acid to bring in, that's really dependent upon our sequence of nitrogenous bases, our base pairs. So whether it's AAA or AAT or CGT, those three-letter combinations code for different things, and that coded message then can be translated and transcribed then translated ultimately into this thing called a protein. So the handouts that you got today are going to be used today and then tomorrow and a little bit over the next day. The big sheet versus the little sheet, okay? We're going to be working off this little sheet today, just for the record. But we're using the table on the big sheet to work on this little sheet. So when we talk about DNA sequences, a DNA sequence is a whole lot of base pairs. Hundreds of millions or something, I think is what one of the, I don't remember if it was Watson or Crick mentioned. But it's a lot. And the order of those base pairs code for different things. So the model that we're going to use is we are going to go through and we are going to use DNA as a way to like code for a message, and we're going to be able to use it to spell words. I believe that you could say it's kind of like a cipher. It's a secret code. It's a secret message that you can't know what's being said unless you have like the key or I think a cipher would be the right term to kind of crack that code. But a thing that to kind of make our model a little bit more parallel to DNA and mRNA and proteins and everything, is when we talk about amino acids being coded by a base pair sequence, it's 3 base pairs at a time. So when we use DNA, A's, T's, C's, and G's, to code for letters of our alphabet, we are also going to use 3 letters at a time. And when we talk about 3 letters at a time, we call that a codon, just for the record. So we are going to look at 3 letters at a time, and 3 A's, T's, C's, or G's in the sequence that those are means something. And if we change that sequence, we may or may not change what we're talking about. And we can use it to write letters, which then ultimately we can spell words. So 3 letters, we need 3 letters to make up we need 3 A's, T's, C's, or G's to code for 1 letter in our model. Because we need 3 A's, T's, C's, and G's to code for amino acid when we make proteins. It's kind of the connection we're going to but we need to know when to start coding and when to stop coding. So when you skim in a book, you know you're keying in on a key thing. You're looking for a key word, and oh, I care right here. I'm concerned about right here and from right here on. And the way that this happens in DNA, or when we code for messages, is we are looking for a start codon. Okay? We need to have a start codon in order to start spelling a word, because we're going to spell words with this hidden message or this code. And there's 3 A's, T's, C's, or G's that collectively make up the code. So if I want to spell the word Star Wars, before I can spell the word Star Wars, I need to key in and say, hey, pay attention right here. I'm going to start spelling my word right here, just like on the board. Obviously the word was he, but there wasn't that cue of saying, hey, start spelling the word here and stop spelling the word here. In DNA, there's a sequence, and it's always it's a sequence, and it's the same sequence for our model. So what I need is I need a start sequence. And it's a 3-letter combination, and it's a choice of A, C, G, or T. Now the way this table works, it gets a little kind of confusing at first, but hopefully the more you use it, you'll be like, oh, that's not so bad. The idea is, we also kind of have spots, right? So the A is in the first spot, and then there's blank blank, because we look at 3 letters, there's a 3-letter combination that codes for anything inside the field here. There's 3 A's, T's, C's, or G's that code for it. So the first spot is like a row. The second spot, blank letter blank, represents a column. Blank letter blank represents a different column. Blank letter blank represents a different column and a different column and a different column. And then the third is a little bit more specific. So I'm going to do this with mine. I would probably not recommend you do this just because this is going to get really messy otherwise if you do. So I'm just going to do it on mine to kind of show you. I want this. So my first letter, and again, I would not do the coloring because you're going to use this over the next day or 2 or 3. My first letter, this letter T, will give me anything in the row that I just shaded. Okay? So I want this box, so my first letter is T. But if I wanted this over here, I wanted this specific location, my first letter would still be a T. So I need, in my word Star Wars, I need to code for a start first. So before I can start spelling the word Star Wars, I need to say start. So my first letter is the shaded row, and my first letter of my start codon is a T. My second letter comes from a column. And now I want this against, so now my second letter, right, because up here it says second letter. My second letter gets me everything in this column. Okay? So my second letter is blank A blank. So I already determined that my first letter, the pink purple row, was T. Based upon the position of my start, my second letter is the letter A. And now I want, very specifically, I want this location in this. So this last one is really just going through, and it's chasing that across to the third position. Okay? So this third letter over here is blank blank C. So because I wanted this position, my first letter was pink, or purple, T. My second letter was like yellow or orange or gold, or I don't know what color that is. It's A. And then my third letter is very specifically that single row within that. So my third letter is the letter C. Now, do you see start anywhere else on that chart? Nope. There's only one way to start spelling a word, and it has to be TAC. It has to be TAC. It's the only way you can start a letter or start spelling a word is if you have a TAC, because that says start spelling my word right here. Now, how do I know when to stop spelling the word Star Wars? Gotta put a stop in it, right? So there's a stop in this. How many stops are on that message? Or in that chart? There's one and only one. Real quick, what if I wanted this right here? It's the letter I. What would be my first A, T, C, or G that I would have to use? This one, very specifically right there. It would have to be C, because C represents everything in this row. What would my second letter be? C, because it represents everything in this column. And what's my third letter going to be? Oops. G. Okay? How many I's are on this chart? 3. There's 3 I's, right? I. Are there 3 different things? Are there 3 different combinations? How many different, excuse me, how many different combinations of A's, T's, C's, and G's are there to then code for the letter I?
3.
There's 3. Do they all code for the letter I? Yeah, right? I could go C, C, A. I could go C, C, C. I could go C, C, G, but they all code for the letter I. The point I'm trying to say is they all code for the letter I, and it doesn't matter which one you choose. Okay? So the letter S, because we're going to spell Star Wars. How many S's are on this chart? Also 3. Okay? There's an S, there's an S, and there's an S. If I chose this S, what would be my first letter? G, right? If I chose this S, what would be my first letter? And this one would be also a T. It doesn't matter which one you choose, as long as you code it correctly. So given the choices between 1, 2, and 3, which S do we want to code for? 1, 2, or 3? Someone gets to pick. 3. Okay, so we're going to code for that third one. So what's my first letter of this S going to be? T. What's the second letter for this S going to be? G. And what's the third letter for this S going to be? C. So it's going to be T, what did we just say? T, G, C? T, G, C. Those 3-letter nucleotide called a codon, that codon codes for the letter S. That codon codes for the letter S. And then we kind of keep going, and we'll continue, we'll pick this up again tomorrow. But the idea is we can hide, or DNA hides messages. It codes for messages, and that message is hidden in there. Oh, shoot, I almost forgot, but good thing I still got like a minute and a half. At the beginning of this semester, Mr. Rather informed you guys via a video that at 4 weeks into the semester, that's this Friday for the record, that progress reports will be determined and off-campus privileges will be removed if you don't have C's or better. Okay? So C's or better, you keep your off-campus privileges. Below C's, LPs and Fs, you lose off-campus privileges. My point is, some of you still have to make up tests, and until you finish those tests, those are zeros, which I'd hate for you to lose your off-campus privileges because of an unfinished test that you didn't make up.